Hello. All right. So now it's time to dive into evaluation. This whole notion of how do we determine how well our search engine is working. Now, in particular, we're going to be talking about what is termed offline evaluation, which is the primary form of evaluation you will see in information retrieval textbooks and so forth and so on. There's certainly also evaluation that can be done with users in a user study scenario. You could kind of think of it like almost like a usability test for human-computer interaction, or other sorts of comparisons where we have live users. And as well, and we talked about it at the beginning of the course, you can have online evaluation where you have your running search engine, people are actually using it, and you're measuring things about their usage of it. So we've got sort of again sort of user studies that we could conduct, and those would be offline, but they're with people. We have offline evaluation. This is what we're really going to get into, which is how can we have sort of an efficient, affordable, a repeatable process to evaluate a search engine. So in other words, it's not going to involve live human participants in a study. And then of course, then there's this online evaluation where we're monitoring a live search engine, but we're not going to dive into that either. All right, time to get going with this. So we left it as there being three major sort of things that we do to evaluate systems. We gave this example of the factory, and now we're applying the same notion to an information system. And those three things were, you observe the system, you're going to create some sort of model of it, and then you're going to use that model to be able to make predictions. And the idea being is that once you have this model, you can maybe change the ranking algorithm within there and see, all right, what do I predict the change in quality is going to be? All right, let's look at this in a little bit more depth again, what we actually mean by this. So this observe is all about really kind of starting for a search engine, which is to observe your users. You need to get out there somehow and see what they're doing. Now, I would not say that an online measure, so in other words, just, oh, I'm measuring the clicks and stuff, that's probably not what you want. You probably need to see more in detail about what's going on, but it would be good. You'd be observing the online users at least to a certain extent. You might not understand quite what they're doing. It'd be better to see them in person. But no, something where we're observing the system in action. And then, this goes along with basically also thinking about, as you do this, what is your measure or measures of success, or how are you going to know if it's working well? So you'd be observing, and you should be able to think about what it is that you really want to know. If you want to talk in sort of more business speak, this would be the KPI, the key performance indicator, or KPIs. So plural, you have more than one indicator that you're using to understand the performance of the system. I've never seen this in information retrieval though, so it's not information retrieval speak. We'll talk about evaluation measures, evaluation metrics. We'll talk about effectiveness measures. We'll have other sorts of measures and things that we do when it comes to these user studies and stuff. So there's all sorts of things that we measure. We don't talk about KPIs, but the idea is largely the same. We have to have some way of measuring the system and detecting is it working well or not. And we certainly should have an idea of what's going on here, and a way that what sort of our real goal is for measuring. We might have to substitute in some other notion of measurement, but at least if we had the real world, what would it be? And what do we understand about this world? Because we're going to need that to get into the modeling aspect. So when we model, we're going to dive in now, which is you have to think about this. How are you going to model users? And it's not just the users, it's also the search engine. And from this model, there's got to be some way to estimate your measures from the model. Or what is it that you're going to get from the model? Hopefully, at least if it's not the measure itself, it's something that you think is predictive of what, or correlates with your true desire of what you want. This really breaks down into three steps. First, we create our model. Then, with a model, we calibrate it. And this is to set the parameters of the model. It would be usually parameterized in some way, some fashion. And by the way, model is taken very broadly here. It could be a simulation. It could be a mathematical standard model. There's all sorts of possibilities for what it is. How are we going to set the various parameters? Usually, again, the calibration goes back to reality. How do we set those so that this model, when we then go to our third step, which is to validate the model, that it seems to actually be predictive. So this goal here is reproducing with our model this real world. Again, great example always to me is just something as simple as physics. Yeah, here we go. We're gonna drop that ball from the top of the building. What are we gonna need? What are we gonna use to model it, and so forth and so on? And what's one of its parameters? Well, it's the rate at which things acceleration from gravity. Oh, okay, because that model is true in lots of places. It's not, so if we ignore air friction, it's not a perfect model, but it's close enough. But it does have a parameter. If we think about, what would it be if we were to drop the items in another part of the universe? We'd need to be considering what our constant of acceleration is. Anyway, so we got those ideas. So what are we going to do? And the validation is are we making good predictions from this model? Does it really seem to do what the reality was here? And then finally, now that we have that model, we think it's good, it's functioning. Now we go and we use our model. And you're gonna change your search engine. This is the search engine that's part of the model, because again, it needs to be part of this overall system somehow that you're going to do this. And the big thing is now we're going to do a prediction. Okay, you're going to predict your measures that the model was used to create, or measures of interest. What is it? And the idea being is, well, we could try, for example, lots of different, imagine different ranking algorithms for our search engine. Those would plug in to the model, and from that then we get predictions of whatever it was that we cared about. What was our sort of key performance indicator? That's the idea. Now, you won't actually see, if you look in many textbooks, it presented this way. I think this is it's not a super new idea, okay? Obviously, existing fields such as industrial engineering, management engineering, whatnot, have had this notion, and even just science for a very long time. Okay? Observe the world, model it, make sure your model is predictive. And then this is the one where we get to play around with the model, that this is much more like taking the simulations and modifying the simulations. This is the thing that lets us estimate whether our changes will be valuable without having to try them out with a real experiment in the world. First, we get to try them out here, and then if they seem good, then we try them usually on a trial basis, and then roll them out to everyone else. All right. Now, I want to note some things about this process. So I'm all over the place right now. I say, oh, you're probably not going to see this in textbooks. Yeah, most of the textbooks are older than this. This idea is becoming more and more prevalent, I believe. There is an overhead to it in that, wow, you're going to have to observe and model and predict. It's a fair amount of work to do this, but it is a way to end up with a process that allows you hopefully to do something where those predictions are useful to you, rather than sort of I hope what I'm doing is predictive. We also have a lot of stuff historically in information retrieval with evaluation that is based upon common sense. It's actually good common sense. That these common sense measures have been able to drive the field for decades. There were some controversies that perhaps they ignored users and things, and this is partly a strong response to that, to say, no, there's nothing wrong with the idea of observing, modeling, and predicting. This is what science does, so we can do the same thing in information retrieval. It's a very complex problem because we're dealing with humans and trying to make predictions, but we can do this here as well. Perhaps I'll be able to get more into the history at another time. Nevertheless, one of the things I wanted to mention about this is absolutely that I mentioned changing the ranking of the system. I regret that I erased my whiteboard now because I'm not pointing at anything. But I want to note that it is possible to evaluate changes to the user interface. This is similar to when we give the example of figuring out things for the factory. You could actually try rearrangements, so people on assembly lines would be working in different ways. It's like changing the user interface. The users are going to use the search engine in some different way. Now, it's not trivial to do that. If it is trivial, it might mean that in many regards, we are going to be making things up and we're going to just be seeing about possibilities. We're not really going to make good, solid predictions to make final decisions about should we make this change or not. We could be doing some things speculative that says, well, if users behave like this and I make my user interface like this, my performance would be like this. That is possible, and it could be useful because you could envision, under best case scenario, they would use my feature this way in your user interface. And if that doesn't seem to actually help things, well, you've eliminated weight and you've saved yourself, say, a lot of wasted time and effort. So it is possible to do it. There's different levels of doing it. By the way, and so there are things in HCI where they basically have low-level understanding of human mental processing, behavior, visual scan rates, and things like that. They have these very low-level models of human behavior and human performance. So what I will say is if your model is low enough or low level enough, so in other words, it really gets down to, oh, people look at this, they will do this, they make these sorts of decisions, and you could actually model that. You can then go and make predictions of user behavior, for example, over different interfaces. Now, why am I bothering to mention this? I think I want to mention it because it's too often assumed that our interfaces are always fixed, and the only thing for us to ever change in a search engine is the ranking algorithm. And that's absolutely not the case. So keep in mind that a search engine is absolutely, you have this user interface, but it is combined with the algorithms behind it. Okay. So we could design new search engines with different interfaces and also different algorithms. It's not just we have one user interface for search engines. Now, we might decide to observe a particular search engine, model it, and make predictions, absolutely. But we could change the interface, ask people to use it, observe how they seem to behave with it, and continue the same sort of process. So this is important because there might be big advantages to actually improving the performance of systems by changing the way the user interface on them. Just because it's a search engine and we've become so used to the way search engines are, doesn't mean there aren't ways to change what is shown on the page, which might improve the rate and performance of users. So you take, for example, even the query biased summaries. So these little snippets of text that you get to read. You could try out and do a whole bunch of different algorithms, and you might actually come up with better ways to create those summaries that more people are able to determine by looking at them whether they should click or not. They don't waste their time clicking on things that are not useful to them. Now, how are you going to put that into a user model and evaluate it? It might be really hard to do that. We may not know how, we probably don't know how to do that yet. But when it comes to improving your search engine, don't only think about things that are easy for you to model in this offline fashion. Think about also the other things that you could actually do with bringing user participants in to study them, or even online tests where you some users get one user interface for the search engine and others get the others. And it could be a very small change, color changes and things. And then maybe through your online measures, you could actually detect something. We're primarily going to be talking about offline evaluation, and in offline evaluation, it would be very cutting edge to try to evaluate an actual user interface change. So that would not be commonly done today. We still have so much to learn about how people interact with search systems and the user interface parts that we're not really to that level of how to model that. But there is definitely a direction, and people have looked at these sorts of things. But don't forget, you might be able to improve things with the search engine interface. And in fact, there's really three parts to a search engine that you can consider improving. You can improve the user, the interface, or the algorithms. And of course, you can improve any combination of them or all of them as well. Now, what do I mean by this, though? I already just talked about interface and algorithm because that is the search engine. But the user, what does it mean to improve the user? Well, you could actually have user education. we could actually teach people about the search engine. You could ask them to watch a video that gives them education on how to be a better searcher. If everyone watches that video and we, on average, we get a 20% improvement in people's ability to find what they're looking for or something, we haven't changed the interface of the algorithms, that's actually a huge win. So let's not forget that there are things that we might also be able to do that actually can improve how people use the search engines, not just from building them, but through our education and other components that could absolutely be a valid approach. All right, so we've talked sort of at a high level introduction to this evaluation where we want to observe people, then model, then predict. So let's go ahead and take this a little bit further. All right. Let's dig into what are some of the things we know about the way users use search engines. There's actually been a lot of studying of it, thankfully, but there is still a huge amount more to be known and to be understood about the way people use search engines. But so let's talk about observe. So because through understanding the way people use search engines, that's going to give us more insight about the various ways that we want to evaluate them. All right. So this really, again, this is, we should ask and get into the question of what do we know about how users use search engines. Likewise, get to how would we measure some notion of quality or success or something along those lines. So first we're going to dig into this about users using, and then we'll talk a little bit about measuring. I want to point out again, though, that sort of this big picture of everything that users do is complex. People turn to search engines for a huge amount of information needs, and their usage of them, we don't know everything about how they're using them. Even if you watch those Google videos, Google says, oh, some large percentage of queries every single day they've never seen before. So there's always new behavior and new things that people are doing. So it's a very big problem. We know a fair amount, but it is definitely incomplete. I would say again, but we do know some details about the search process. And this is an ongoing thing, is to study this and understand it better. All right. So let's start at the very beginning with regard to users. What are they searching for? What is the nature of these queries and information needs that they have? So there's this paper, I've put it in Learn. It's questions versus queries in informational search tasks. This is by Ryan White et al. And this was published at WWW 2015, the World Wide Web Conference, now renamed the Web Conf, I guess. Anyway, so he wrote this short paper, And what's one of the things I like, it's not so much as the whole paper that's great. It's that it's a fairly up to date look at the types of information needs people have when they're querying a modern web search engine. And so back in 2015, and I know that seems like a long time ago, but the other studies are even older and certainly out of date, by the way. So what they do is they collect a significant number of queries from their search engine. Then they basically, usually the way this works is you have multiple people separately say and classify and come up with some sort of taxonomy about what's the type, what's the category of this search do they think the user is actually doing. Then they have these multiple people compare what they thought and they adjudicate between them until they end up with a final decision about what was going on. So we can look at the percent of the queries that are coming in and are falling under these different categories that they have. The most prevalent category are what are known as navigational searches. And so these are when people type in Facebook and their only goal is to go from Facebook, go to the query to click the link to Facebook. Yes, Facebook is a very, very popular query. I want to log into Facebook, so I type Facebook into my search engine. I hit search, and then the first result is Facebook, and I click it. They don't type facebook.com. I don't know why, but this is what they do. Likewise, there's all sorts of things. Like you want to go find the homepage for the University of Waterloo. That's a navigational query. It's where you want to go to a specific website. You know what that website is. There's only one answer that you care about. Those are navigational queries. These make up, in their work, made up a whopping 54.4% of the queries. So just rounding, we're talking half of the queries a web search engine sees are, I want to go to this website. I want to go to this company's website. And it's an important query. You need from whatever is type to figure that out and to figure out that that is that type of query so that you give that result to people. But it is not the type of query that we'll be talking about in this course, or the ones we'll be studying. We are instead looking at the more traditional ones. The ones we're working with are informational. So this is usually where someone wants to learn something. They need some information to find something. We talk about helping people better satisfy their information needs. Now, navigational are part of information retrieval for web search engines, but informational is what we more commonly think about, especially in this course. And they make up a good chunk, though, 31.8%. All right, and in the paper, they actually break down the informational into different types. Then there's a much smaller amount where these are called resource queries. The big idea here is they want to download something or get something that's out there on the web. They want a particular piece of software to download or so forth. And it's clear that that's what they're doing. They're not trying to get information about those items. They're not trying to go to some particular company's website. They're trying to actually get something, and they know what it is that they want. This makes up 6.9%. Then there are some queries where people are looking for pornography. And these make up 2.7%. What is interesting about this percentage is that in the early days of web search engines, I believe it was much higher out of the total percentage of the searching. I don't know what exactly has changed other than the fact that perhaps people have learned what vast utility search engines really are for their everyday thing of life, of first getting to places they want to go, but really making up a big chunk of it being the informational queries. People are probably issuing overall and using search engines a lot more than they used to, and then actually changing the amount that we see for these sort of adult requests. And then there are a smattering of requests that come in that are clearly what we would call sort of errors. Often these are copy and paste, where someone has accidentally copied and pasted something into the search field and hit search, and it is not, they didn't want it. That wasn't their intention to do a search. That makes up 4.2%. All right, so big thing, navigational and informational. And resource is again, I want to go to a particular thing, and then we've got our adult queries, and then other stuff, mistakes. So the big ones are informational and navigational. Now, the big thing is what does this tell us? Well, if we do a little bit more looking or thinking about it, users behave very differently for nav or navigational queries versus these informational queries. All right, very big difference. When you look at what users can do when they type in Facebook, and in a fraction of a second later, they've clicked on the link and gone to Facebook. It's automatic. They know it's going to be there, that the search engine works and has put it at rank 1. They're not looking anywhere else on the web page. Okay, navigate, and with a navigational query, do you want to navigate to more than one place from your query? The answer is no. You want to go to this place. I want the home page basically of this entity. That's it. That's one click that we want, where the person wants. They're not studying about navigational queries. They just want to find a link and click on it. Thus, that means, to evaluate web search engines, you very much need to consider both info needs when you're going to evaluate and measure and make predictions. So you can't just say, oh, I'm going to only build my search engine for informational queries, and leave out that 54% of other navigational queries and not even find out how well you're doing on them. I think users, if they're using them so much, you'd better do those right. You better get them right. And just to point out how tricky this is, some queries could have both information needs behind them. So one, I need the web page. The other one, no, I want to learn more about this. I want to probably read several things about it. Let's take an example. Someone gives the query, University of Waterloo. Woohoo! What do they want? Well, pretty clear. They could want to go to uwaterloo.ca. They want to find that web page and click on it and go to it. They don't know that the URL, the domain name is uwaterloo.ca. So they need the search engine to help them find that. And they want to click, they're going to go, and that's going to be it. But they could also be at the stage where they're like, I want to know about, the rankings and so forth and so on. I want to know what the type of students are, how many faculty are there, all sorts of information. What's the history of this university? So they want to learn more about University of Waterloo. And typing in University of Waterloo is a perfectly fine thing. want to learn more about it then. So you get one query in and you get two types of behaviors, but you're only producing one ranked list. I doubt there's any way that you could predict by the type of, the notion of the person typing in that query which one they want. Maybe historically, if you keep seeing someone come in and type in something and click only on that one link, you might be like, well, that's what they want. They're a navigational user for that query, maybe, but for the average person, you wouldn't be able to tell. And so your search results that you return have to cater to both of these, which means when it comes time for us to do our modeling, when it comes time to do our evaluation, we need some way to be able to capture this combination of people coming in for this one query that we would be like, well, how well does the search engine work when people query University of Waterloo? We would need to take both of these into consideration. All right. We, again, though, are going to focus on informational queries. We're not going to look at navigational queries. One of the reasons being is all our homework is not a web search engine, it's just a plain old search engine. We don't have web pages and things like that. So our tasks in the class are strictly traditional information retrieval. We're trying to find a whole bunch of information usually and learn things. All right. What else do we know about users from our observations that we probably should be thinking about and putting into consideration when we model? So that was something to particularly look at web search. But let's just say, yeah, we're going to focus on these informational needs. Are there things that are common to it and other sorts of behaviors? Well, so we know very much, the common user interface today is what people like to refer to as the 10 blue links. So yeah, we'll do 10 search results. Microsoft's Bing search engine actually, I don't know if it still does this, but for a long time, it actually had gone to, we're just going to give you 8. And you know what? If we see you click something and then go back to the search engine, we're going to auto-populate and make that list longer because maybe you'll need to go down further down the list. It was a pretty nifty thing that they did. Why 8? Well, it loads faster. Lots of research has shown that users will use search engines more frequently if queries come back faster. Anyways, 10 blue links. All right. You got 10 blue links. And so what does this mean? Again, this is, you have some page, someone goes, you got some sort of search button, you type in your query, you get go and get these results. You get the first result, the second result, the third result, and so forth up to 10. And that's the way it's presented. I mean, I'm almost embarrassed to draw it because of course you've used search engines, you know that that's effectively the way they are. They don't number the results, but that's what they are. Now, the one search engines you're using today, of course, have lots of other elements on them. They've got ads on them. They've got often special windows that break out. There's all sorts of choices. It's not this simple, but this is the sort of the paradigm that we're in and we're talking about. So when we have search engines with user interfaces like that, people, and this was from the earliest days of search engines, they had this form. And what did people notice? One of the things they saw very much, because they were able to collect lots of data really quickly, when they looked at the rank of the resulting search results, rank 1, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 10, and then they looked at, what's our click-through rate? Because of course we're curious about, are people actually clicking on the results? That might be one indication, are we doing a good job? They're clicking on the things that we're returning to them. And so let's monitor this click-through rate. One of the things they saw pretty quickly was that the behavior, is very much, falls off really quickly. So maybe rank 1 gets clicked 30-40%, somewhere around there, the amount of time for when queries come in. This can change because the modern search engines are so great often at being able to satisfy you with the results that they show you. So if you type in, weather, and you're actually looking for the current weather, a lot of search engines will be like, we'll do a geolocation, they'll look up where your IP address is, they'll give you the current weather and temperature or something, and you don't click on anything. So there's that's what we would call good abandonment. But you didn't click on anything. It's like you abandoned the web page. Oh, but it was good that you did because you were satisfied. Bad abandonment is this concept of you got a web page back and you're like, that is junk, and you don't click on anything and you put in a new query. That's bad abandonment. Anyways, so you're gonna get this, and it falls off really quickly. Then it takes another dive once we go past 10. Very few people actually say more results and go on to the second page, and even fewer go on to the third page, and so forth and so on. Almost all of the activity that users have is within the first 10 ranks. This is for a web search engine, okay? This is the nature of the way they're used. If you were doing a company internal web search engine, things might be different. Maybe Amazon's search engine, when customers are searching for products, maybe people behave very differently there. This is part of the whole observation. How are people using your search engine for their tasks? You need to learn about this so that you can have, when it comes to evaluating it, you can build a good model that reflects reality. So we know this. We know this happens. Why? Why does it happen? Well, there's two big causes to this. And again, these causes sort of influence our understanding about how we might then choose to model. So again, observations inform us, like, what do we need to take into consideration for our models? Well, one thing certainly is when users find what they're looking for or what they want, they're basically satisfied, they stop clicking. So think about all those navigational queries. I want to go to the homepage of the University of Waterloo. Google puts it at rank 1. You click rank 1. You're not going to click anything lower down. This goes into the overall statistics of the click-through rate. Also, maybe you only need a single page to satisfy your information need. You just needed some information. There it was. You got it. You're done. So when you find something good, maybe a single web page is all you needed. So you don't come back and click something further down in the rank list. So often when you find what you're looking for, you stop. Certainly there are some informational needs where you're like, no, I need to find lots of information about this thing, and you're going to click on lots of things. But overall, this is the behavior people see, and one of the reasons is that people do stop once they find they're satisfied. The other thing is that users don't look at all results. And this is not just because they found something and they're done. This is separate. Even if they're not finding what they're looking for, they often will not look at all the results. And the big point here is that if you don't look at a result, I don't want to say cannot. You could close your eyes and go click. You could, but basically is, you don't click on it. Can't is probably okay to say, but you don't click on it. Because it's never gone into your consciousness. For those of us who are sighted, we look things that we're going to act upon. If I never looked at a search result, I'm never gonna click on it because I might know that there's something at rank 10, but if I never looked at rank 10, I'm certainly not going to click at rank 10, because for me as a sighted person to click on it, I need to look at it to find the link and click on it. So we know that people actually are not looking at all of the links. How do we know that? We are able to do eye tracking experiments with users. So you come into a lab, it's got this eye tracking device which has 2 cameras in it, one a normal camera, one an infrared. It's calibrated based upon your eyes, and based upon where you look, where your eyes move, we can actually see and record what you were looking at. So we have people come in, use search engines, and they don't look at everything. All right, that's one of the things that results in this. Besides stopping, they also don't always look all the way to the bottom of the list, even when they're not finding what they're looking for. They'll stop looking and they'll actually then either give up entirely, or they'll go and they'll change their query and put in a new query. All right, so we've got this behavior, and this tells you something, putting a document down here at rank 10 is a lot less valuable to a lot of users than putting it at rank 1. They're going to see it at rank 1, and if it's the right document, it's going to get clicked on. If you put it at rank 10, there's a good fraction of people who won't even ever see it. So it has no value to them at all. So value basically decreases the further it goes down in the rank list, and it falls off actually quite quickly for web search. Again, web search is not the only form of search out there. You would want to understand this behavior for your search engine, for your tasks that people are doing. What is the behavior that they have? All right. What else do we know about users that could inform us about how we should go about modeling and measuring success and quality of a search engine? I could do this for weeks. We could talk about this, but I'm trying to hit upon some of the major things that do get incorporated into models. Another thing is, the more likely a human relevance assessor, so this is someone we hire to look at a document, all right, the more likely a human relevance assessor thinks a document will be relevant to a user. In other words, we don't really know what you're looking for, but based upon your query, we think that this might be a really good document for you, so we think it will be relevant to you. To a user, what we do find is it is more likely that people will click on it. And it actually, if we ask these relevance assessors to sort of grade the quality of how relevant do they think it's going to be to people in general, how sort of important is this page, the more important it is from that relevance assessor's perspective, the better the document it is, the higher the probability people will click on it. It's a continuation, all right, where of course the assessor who thinks something is not relevant will have the lowest probability being clicked on, not a 0 probability, because for some reason, again, the assessor doesn't perfectly know the user's information needs. So the user might click on it, the user might make a mistake, all sorts of reasons. But in general, we can definitely see that, oh, okay, it does work this way. It makes sense, at least. That's good. So we know that. That's nice to know. You again, imagine you could be putting this into a model. Oh, my assessors say this document is a 4, and that document is a 2, and that document's not relevant. Okay. And then when it comes time to the model, we could be modeling probabilities about which users will actually click on things. This sort of stuff can go into our model of the user behavior, which translates to most likely models of how successful users are at finding relevant information. All right. The other thing, you're going to be like, oh, that's not surprising, but users, for the most part, they work down the rank list. They work down the results. They go from the top of the page down. Certainly, there is some up and down movement. Again, this is from eye tracking work. So we certainly, some users will scan down the page, and then others, then they might scan up a little bit. Some do this a lot more. Some just try to very strictly go down. There's all sorts of nuanced and different categories of user behavior, but largely in general, they head down the page. Okay, so that's good to know. It's not like people are like, I think I'll go look at the bottom of the page and work up. That's not the common thing. But anyway, we could see users, maybe users would always read all the results before deciding what to click on. That's actually, we know that not to be the case. So they're a scroll down. They might do a little bit, but then if they see something, they'll usually click on it. All right, and that's the way it works. Okay, so those are some big things that we should all know about user behavior. You know, the types of queries that people are coming in. So if you're going to build a new search engine, what are the types of queries your users are doing? And again, not all search engines are web search engines. Let's understand our users. What is their nature of interacting with the search engine? You know, all these sorts of things. Let's get a good understanding of this. Now we're in a good, while we know lots of stuff, and you could study that for, let's say you've got some company and you're studying the users, I will point out that there is lots we don't know yet about how people use search engines again. So for example, how, you know, we've studied this, but I would say our understanding of it's not very deep yet. You know, there are things like people who issue multiple queries to be able to find things. So they're not satisfied with one good query, then they issue another and another. And what really is that process? And how could we understand that process? What triggers doing a new query versus not doing a new query, and so forth and so on. That's just an example. There's lots that we don't know yet. It's a fascinating area, and there's lots of studying to be done about people's behavior with search engines. All right. So, but then this brings us to the big point, which is what might be possible measures of quality? What could we actually do to measure, is the search engine working well or not? Think about, by the way, again, back to the old-fashioned, the classic search engine called the library. How do they know whether things are working or not? Well, traditionally they had, measures such as number of books checked out of the library. The more books that are checked out, the more people must be happy in finding and reading things that they wanted. Likewise, you can do things, you can be like, how many visitors do we have each day? So in other words, how are people using the library coming in? Just basic traffic statistics. And of course, they could do things where they could send someone around with a tablet and say, would you like to take part in a survey? And they could take part in a survey, but that's again, that's more like a user study or something like that. So there are measures that they had. So we could, they could also look at to what extent do people reuse the library. Oh, you checked out a book once. Did you ever check out one again? Did you use the library again? So you could envision for a search engine, you could be measuring and want to know things about like return visits. How easy is this going to be for us to model? I don't know. I think that would be a real big open research question, how to do that. Something a bit easier might be number of relevant documents found by the user. Maybe we could do this. And this is where we'll spend some time modeling this. So a number of relevant documents found. All right. Yeah, that's possible. We could observe users and measure that and get all sorts of statistics. And then we could try to model that and see if we're able to predict that as well. All right. There's this big question about satisfaction. We'd love to be able to estimate user satisfaction because satisfied users mean the search engine's working. So, we could bring people into a laboratory, have them use the search engine, do tasks and say, were you satisfied? So we could observe behavior, collect data, but then we have to figure out a way to model and make a prediction about satisfaction. There has absolutely been work on this, okay? There's not a fantasy trying to predict satisfaction. And in fact, major web search engines absolutely. Based upon this behavior that we are able to observe for online users, we have this estimation of what fraction of them are satisfied searchers, okay? If we could model the user behavior accurately enough, we might be able to also end up capturing some notion of, when we model and simulate a user with this system, and the simulated user has this behavior, then we could maybe predict satisfaction. There's all sorts of possibilities. So it's not out of the realm. So these are sorts of things that people absolutely are like, yeah, I want to be able to estimate this, and I want to come up with a model that could report the notion of satisfaction. All right. You could, now I think this is outside the realm maybe at the moment, but some people have looked at measures of frustration. So is the user frustrated or not? So you'd want a lack of frustration. Something that I'm personally very interested in is the notion that people come to search engines. Sudame, a famous researcher, says, people don't come to search. In other words, they come to search engines to do tasks. They want to go somewhere, they want to learn something, they want to fix their washing machine, whatever it is, they have a task. They want, for example, to find out whether a health treatment they've heard about is helpful or not for a health issue that they might have. So they turn to a search engine to research this. So there you go. Now you've got something. They're going to try to learn, basically, should I take, let's say, some drug? Should I do this treatment? And they're going to be making a decision. Now, a possible thing that we might want to do is to be able to estimate or measure the quality of their decision making. Okay? So for example, those health search queries, absolutely. With the web filled with misinformation and people trying to sell you all sorts of quackery medicine, there is, for this sort of consequential decision that you're going to make, should I take this treatment, use this treatment or not for my health issue, you could potentially make a very bad decision. I'm going to use this to treat my cancer rather than what my doctor says. I hope you don't do that. I hope you don't fall prey to those things. But the thing is, when people are in desperate need, anything that tells you, I can help you, it becomes so much more appealing than when you're not in need. So, but are our search engines helping people make good decisions? To what extent can we model and understand the decision-making processes that people have when they use a search engine for decision-making tasks and be able to then predict that? And so this is an active area of research right now. So fascinating. There's all sorts of things that we consider and look at for evaluation. All right. But I already gave away where we're headed. We are going to look at this one. Number of relevant documents found. We're going to work through an example of how to model this and end up with an evaluation measure. And so, yeah, we are next going to dive into how do we go about. So this is sort of the observation stage. This is the broad strokes of it, some of the things to think about that inform our models. When I talk next about starting to create the model, we'll talk in particular about the observations done that were necessary to be able to calibrate and validate that model. But yeah, we're going to look at an estimate of the number of relevant documents found as a way to measure this. We're going to look at people who have informational needs where they want to find multiple documents, for example. All right.